All right, let's talk about a material that is probably within arm's reach of you right now. Polyvinyl chloride, or as we all know it, PVC. It's cheap, it's tough, and it is absolutely everywhere. But as you'll see, this story of incredible convenience has a really dark side.
And that really gets us to the heart of the matter, doesn't it? Is PVC this unsung hero that built our modern world, or is it a massive environmental liability that we just can't afford to ignore anymore? Let's break it all down.
You probably don't even think about it, but PVC is kind of like a silent partner in your daily life. It's the water pipes hidden in your walls, the credit cards sitting in your wallet, the frames on your windows, and the insulation wrapped around countless electrical cables. It's even in things as critical as hospital IV bags and as common as vinyl flooring. It just quietly dominates all the hidden parts of our world.
And just try to wrap your head around the scale of this. We're producing over 45 million tons of PVC every single year. That makes it the world's third most produced synthetic plastic. I mean, it is a true heavyweight in the world of materials.
So, let's start with the good stuff, the hero story. How on earth did a forgotten lab accident end up becoming the absolute backbone of modern construction? Well, the story starts with a complete accident back in 1835, but for nearly 100 years, it was basically useless, just as brittle little curiosity sitting in a lab. The real game changer came in the 1920s when a scientist named Waldo Semin figured out he could make it flexible by adding something called plasticizers, and just like that, it became indispensable. First, it was a wartime hero used to insulate wiring on WWI warships, and then it just exploded into our homes, becoming everything from pipes and flooring to, yes, even vinyl records.
So why did it get so popular? Well, it all comes down to this just killer combination of properties. PVC is incredibly cheap to make. It's tough and durable, it shrugs off chemicals, it's naturally flame retardant, and it's super easy to shape and form into whatever you need. For any industrial application, that's pretty much an unbeatable hand. And this quote just nails it, really. For decades, PVC was exactly that, the cheap, tough backbone of modern infrastructure. It made things like plumbing and electrical systems affordable for millions, completely transforming the way we all live.
But that's only half the story, isn't it? Now we have to flip the coin and start uncovering the toxic trade-offs that come with this unbelievably versatile plastic.
Okay, and this part is absolutely crucial. You have to understand that not all PVC is the same. On one side, you've got rigid PVC, or UPC. Think pipes, think window frames. It's strong, and it actually gets recycled a fair amount in the construction industry. But to make PVC flexible, for things like cables or flooring, manufacturers have to add chemicals called plasticizers. And often, these are toxic compounds called phthalates. This one simple addition turns it into a recycling nightmare.
And the problems go a lot deeper than that. The very chemistry that makes PVC so useful is also its biggest curse. Its chlorine content means that when it burns, it can release dioxins, which are highly toxic pollutants. Those phthalate plasticizers we just talked about, they've been linked to some really serious health concerns, everything from hormone disruption to reproductive issues. And on top of all that, if it overheats, it can release corrosive hydrogen chloride gas. This material comes with some serious baggage.
Which really leads to this conclusion for the villain argument. PVC may be the king of infrastructure, but it's wearing a very toxic crown.
Okay, so we've seen the hero, and we've definitely seen the villain. How do we reconcile these two completely opposite identities? Well, to do that, we need to weigh the good, the bad, and the just plain practical, and give PVC its final ranking. So to get our final verdict, we're scoring it on 6 key criteria, and you can see it scores incredibly high on historical impact, workability, and versatility. And look at scalability and cost, a 9.5, a truly revolutionized construction by making it affordable. Its mechanical properties are solid, though not top of the line, but the place that really takes a hit is lasting relevance. With all the growing environmental and health pressures, its future is way less certain, and that brings that score down.
So when we average all of that out, we get a final score of 8.3 out of 10.
And that 8.3 lands PVC firmly in the high B tier. So it's not an A-lister, but it is far from a failure.
So what does high B tier actually mean? Well, you can think of it as the ultimate practical workhorse. It's a material that's indispensable in so many areas just because it's cheap and it works. But and this is a huge but, those major environmental and health concerns are exactly what keep it from reaching that top A tier. This is a material that's all about practicality, not perfection.
And all this leaves us with a really critical question. What is the true cost of affordable infrastructure? PVC helped build a cheaper, more connected world, no doubt about it. But it's also a stark reminder that sometimes the biggest costs are the ones you just don't see on the price tag.